Hello everyone, this is Kshitij with Apoor and we are Group 15. This is a video update on our midterm project. We have successfully achieved our target for phase 1, which was to get the IMU tracking working. We are working on visual inertial odometry and it essentially has two pipelines, one for the IMU and second for the visual aspect, which is from the camera. This sensor fusion allows us to effectively track the trajectory and estimate the pose of any robotic platform, which is a racing drone in our case. And coming to the dataset, we are using the dataset provided by ETH Zurich. This has raw IMU data, frames captured by the camera, and the ground truth values of the pose and the position of the drone. Now, for this particular phase 1, we have decided to go with this set because number one, this is closed loop, and number two, it is high fidelity. Hence, it will help us to easily navigate and compare our performance, the performance of our pipeline with ground truth. Now, coming to the results, here we can see our C++ pipeline is able to get the raw data from the IMU and come up with its pose and positional estimates as generated by these XYZ tuples here. And if we were to plot this over time, we can see our results are already super close. The orange graph is the ground truth data captured via the Vicon system, and the blue graph is the estimated data from our pipeline. We can see the roll, angles, then the pitch, and finally the yaw comparisons on the bottommost. There are some sudden peaks and troughs in the yaw, but this is due to the logical implementation in the dataset because since it's yaw rotational angles, when the value goes above 180, it can register as a negative angle and vice versa. For instance, an angle of 185 degrees can easily be interpreted as minus 175, which we can see here. This is plus 180 and this is minus 180. So this is one and the same thing. However, in terms of absolute angles, it's exactly the same. And again, this can be simulated using the commands provided in the video. Thank you very much.